So as been already mentioned, there is only a single instance of a singleton bean, and all the clients requests are basically directed towards the same bean. And like stateful beans, you can actually store state in the singleton bean, and that state can be accessed by all the clients. So it's sort of some global variables. So all this while we have been creating singleton beans for testing your application. But once again, let's create a singleton bean. New bean, and my bean. Okay. Now select singleton over here, and let's select a local interface. So let's go to the local interface and code some methods. So void increment, okay, just creating two methods, and int get number. Okay, let's create implementations for this method. So singleton bean, let's remove this off. So implement all abstract methods, and let's create a new variable. We can store save state in this bean, so number. Okay, and over here we write number plus plus, and over here we just return this number. Now let's use the bean we have just created. So again we are going to test the singleton bean from the singleton bean itself, so there's no problem in that. So it's my singleton bean local. You have to mention the interface, not the bean implementation name, and then my bean, and over here my bean dot increment. Let's increment it once more. My bean dot increment. Okay, and let's my bean dot get number. Output this as out and tab. Let's put this. Okay. Let's save and run this application, and here's the output. Now question can come in your mind that how come a bean had to implement one interface, and how come a tester bean didn't implement any interface? This is because in EJB 3.1 you can create a bean which doesn't need to implement any interface. So let's create an example of a stateless bean without any interface. So my new session bean, let's keep the name as the default is, and let's create a stateless bean, and this time we won't create any interface. Okay, this is your bean. It doesn't implement any interface, it's just a plain old Java object. Since there is no interface, you have to directly use the implementation name. Okay, so that's the only difference. Another difference for a bean which doesn't implement any interface is the bean is always a local bean. It cannot have a remote client. So you can explicitly mark this bean as a local bean, or this is not required. The same as writing this. However, it's a good idea that you always create an interface and let your bean implement that interface, because your client shouldn't have any idea about your implementation. All they should know is just the contract or the interface. The life cycle of a singleton bean is exactly similar to a stateless bean. There are two states, does not exist, and method ready. There is no pool, there is just a single instance for each bean. So in the does not exist state, first the instance gets created, then all the injections takes place, then the post constructs run, and then the bean is ready for servicing the clients. So since there is a single instance of this bean, there are chances that two or more clients can be accessing the methods on the bean at the same time. So some concurrency constructs have been provided for situations when the bean can be accessed concurrently. So singleton concurrency can be of two types. Either the container will manage the concurrency for you, or you can manage it yourself using bean managed concurrency. So Container managed concurrency is we can implement this using read and write locks. And since this is homegrown strategy, you can use synchronized volatile keywords or any facility you want for maintaining concurrency. So even if you don't specify a strategy for your singleton bean, by default this is selected, container managed concurrency. So let's say you want to be explicit by the strategy. So concurrency management, and then you specify the strategy. We can select either bean or container. So after specifying the strategy of container, which was by default the strategy selected for the bean, we can specify locks for the methods. For example, we can say, and then we can mention the type of the lock. So either it's a read lock or a write lock. So by default all methods have a write lock. So this is as good as not mentioning this, because all methods by default have a write lock. What write lock means is, if any client is accessing your method with the write lock, no other client can access your read or write methods. Now let's override the default for this method. So default lock is write. So let's make this read. Okay. Save. Difference between read and write lock is, a read method can be concurrently accessed by many clients. A write method cannot be. Only a single client can be accessing this method. All read and write operations will be stopped when somebody is accessing the write method. So let's see this diagram. So that's what I mentioned over here. When a client with a write lock is being accessed, no other read or write method can be executed. When a method with a read lock is being accessed, then method with read lock can be run concurrently. And container managed concurrency is a default, and all methods are by default write locked. So by default, even if you don't mention any kind of concurrency constructs, your method is safe for concurrent access. We just introduced read over here because reading didn't modify any kind of state, write did, so it should be not accessed concurrently. This can be accessed concurrently. That's the only reason we introduced read over here. Now singleton bean is usually created when it's accessed for the first time by any client, but we can change its default by marking it as startup. By saying this, we mean that the bean will be created when the application gets deployed. It doesn't have to wait for a client request. So this feature we are using sort of as a hook for testing our applications. And as you saw when we were discussing Lifecycle, that first the instance is created, then all the injections take place, and later on the post construct method run, and after this the bean is ready to service the clients. Now you can understand why this bean or why this method acted as our main method, because of startup the instance was created eagerly without waiting for the client, and because of post construct this method was run.